Okay, this video is for sampling with and without replacement. Let's review the formulas first. We're going to use sampling with and without replacement for the multiplication rules. Basically, we need to understand what it means to be able to apply the multiplication rules. So for that, we need to understand what independent events and dependent events are. So independent is when one event occurring does not necessarily affect the other one occurring. So this could be me tossing a coin and it lands heads, and then I roll a die and I get a 5. So those two are not necessarily connected. Me tossing the coin does not necessarily affect what I'm going to get when I roll the die. So we have formulas for this, but I find it's easier sometimes to do these type of probability intuitively. But regardless, we're going to go over the formulas. So we want to find the probability of A and B. If the events are independent, we need to find the probability of A, and then we're going to multiply it by the probability of B. If the events are dependent, so let's say the probability of me getting into a car accident is definitely going to be affected by the probability that there's ice or snow on the road. So that would be a dependent event. So again, we want to find the probability of A and B. We need to find the probability of A, and we're going to multiply it by the probability of B given that A already occur. So that little line symbol, that's called pipe. Let me write it here, pipe. Given that, so this is the probability that B is going to happen, given that, that's the pipe, given that A already happened. So let's do a couple of examples of sampling with and without replacement. This is a very basic example, but it's very intuitive, and it really helps understand the basic concept. We have a bag of 12 buttons, and they have different colors. So we're going to do 4 different events, A, B, and C. Right now we're going to do A pink button twice. First, we're going to sample using independent events. That means also sampling with replacement. So the probability that I get a pink button the first time, it's going to be 3, because I have 3 pink buttons out of 12. 3 out of 12. I put that pink button back into my bag. So the next probability is also going to be out of 12, and I still have 3 pink buttons. So I'm going to multiply this by 3 over 12 again. We can multiply across, so that's going to be 9 out of 144. Recall, these are going to be independent events, and it's also the same as sampling with replacement. Now let's do sampling with replacement, which is another way of saying we have dependent events. So we have 3 buttons out of 12 because we're interested in the pink once again. But once I take that pink button out, I'm going to be down to 11 buttons in my bag. And the first button that I took out was also pink, so I need to take out 1 pink button as well. So it's going to be 2 out of 11. We multiply across, that's going to be 6 out of 136. If we find in the probability in decimals, it's going to be 0.044. So let's start with independent events, which also means with replacement, sampling with replacement. So we wanted to do part B, yellow button, then a green button. So we have 2 yellow buttons and 2 green buttons. The probability for a yellow button is going to be out of 12, so 2 out of 12. We're going to multiply this, again, 2, and the denominator is going to be 12 because I replaced it. I didn't take anything out. And 2 because I have 2 green buttons. We multiply across, and that's going to be 4 over 144 or 0.028. Now let's do the same thing, but we're going to do dependent events, which means without replacing the button into our bag. So we start the same, out of 12. So it's going to be 2 over 12. But I didn't replace this button, so it's going to be out of 11. 11, and then 2 green buttons, so 2 out of 11. We multiply across 4, and then 136. In decimals, this is going to be 0.029. So we're going to do part C, a blue button twice. We have 12 buttons and 5 that are blue. First, we're going to start with independent events, which is also sampling with replacement. So when I take a button, I put it back into my bag. So the probability of getting 1 blue button when I reach into my bag is going to be 5 over 12. I put it back in, so it's going to start at 12 again, and I have 5 blue buttons, so 5 out of 12. I multiply across, that's going to be 25 over 144. In decimals, this is going to be 174. Now we're going to do dependent events. That means sampling without replacing the button into our bag. So the probability at the beginning is the same. I have 12 and I have 5 blue buttons, so 5 over 12. I don't replace it, so it's going to be out of 11 now when I take the second button out. And I only have 4 blue buttons, so it's going to be 4 out of 11. So we multiply across 20 out of 136. And in decimals, this is going to be 0.147. We are going to do part D, a green button followed by a blue button. So independent events, which means sampling without replacement, have 2 green buttons, so that's 2 out of 12. Now the probability for blue is going to be out of 12, 5 out of 12. We multiply across, that's going to be 10 out of 144, and in decimals, this is going to be 0.069. Next, we're going to do it using dependent events, sampling without replacement. So the probability is going to stay the same for the green buttons. So it's going to be 2, because we have 2 green buttons, and it's going to be out of 12 because we're starting with 12. Once I take that green button out, I'm down to 11 buttons. And I still have 5 that are blue, so it's going to be 5 out of 11. We multiply across, it's also going to be 10, but it's going to be out of 136. When we find the decimals here, it's going to be 0.097.